Hello friends, I hope you are doing regular practice and variety of questions at home. In this chapter, I'm going to discuss some concepts and exercise 2.1. This is part 1 video of this chapter, fractions and decimal. So let us begin with what are the different concepts or topics which we are going to cover in this video. The very first topic is we are going to define fraction. Then second, we will do the type of fractions like proper fractions, improper fractions, mixed fractions, what they mean and their examples. Now next we have to learn about equivalent fractions. We are going to compare two fractions given to us. And then we are going to do the addition and subtraction of fractions, and finally we will solve NCERT Exercise 2.1. So now the very first question is, what does it mean a fraction? So the very simple answer to this question is, a fraction is a share or part of a whole. In this picture you can see here we have the shaded part, that is only one, and four equal parts we have of all the entire whole circle. So entire circle is divided in four equal parts and one part is shaded here. So we say that the fraction or share here is 1 by 4. The part of or fraction of circle that is shaded is 1 upon 4, where the selected part or shaded part is called the numerator and the total number of divisions in which the entire whole is taken, that is the denominator. So the entire circle is divided in four equal parts. So here we have the 4 as the denominator and 1 as the numerator. So this is what basically we understand by fraction, a share or a part. For example, you purchase a pizza and you make four equal parts of it, and one part you give it to your friend. The share of your friend or fraction of your friend is 1 upon 4. Similarly, we have here the circle and we have the four part and one part is shaded. So the fraction which is shaded is 1 upon 4. So I hope you are clear about the definition and the concept of fraction. Now next we have proper fraction. What does it mean, proper fraction? A proper fraction is a fraction that represents a part of a whole. Its value is less than 1. Numerator is always less than denominator. So you can understand here we have here 3 and then 5. So 3 and 5, 3 is the numerator here and denominator we have 5. So we say that the numerator is 3 and denominator is 5. So numerator is lesser than the denominator. So it's a kind of proper fraction. All these are the example of proper fraction. 2 upon 3. Then we have 3 upon 6, 5 upon 7. Then we have 16 upon 40. All these are the examples of proper fractions where numerator is lesser than the denominator. So now I hope that you got the clarity of proper fractions with example and its definition. Now we have next the improper fraction. What does it mean, improper fractions? An improper fraction is a combination of a whole and a proper fraction and its value is more than 1. So whenever a numerator is greater than denominator, we call such fraction as the improper fraction. And you can see the example here. We have improper fraction 5 upon 4. So here we have this circle as a whole. So whole circle and 1/4 taken together. So entire circle and 1/4 both taken together, we call it improper fraction because it is 5 upon 4 and numerator is larger than the denominator. So 5 is larger and 4 is a smaller value. So in case of improper fraction, a whole is involved and a part is also there. So the improper fraction basically we identify by observing its numerator and denominator. Whenever you have the numerator larger than the denominator, you can say that it's an improper fraction. So 1 upon 4, numerator is smaller, so it's a proper fraction, but 5 upon 4, it's an improper fraction because numerator is larger than denominator. So I hope you understood the meaning of improper fraction now. Next we have mixed fraction. How can we define a mixed fraction? Improper fractions can be written as the sum of whole and a proper fraction, that is called a mixed fraction. So here the example is 2 1 by 7. 2 is the whole and 1 by 7 is a share or part of a whole. So this is what we call it improper fraction, and all the mixed fractions can be written as the improper fractions. Here you can see that 11 upon 5 is an improper fractions, and it can be written as 2 1 by 5. So when you divide 11 by 5, so you get the quotient 2 and remainder comes 1. So 1 upon 5 and 2 as a whole quotient and remainder 1 upon divider 5. So 2 1 by 5 is an example of mixed fraction, and where we get it from? We get it from an improper fraction, that is 11 upon 5. So mixed fractions are basically the combination of sum of whole and proper fraction, whole and part, whole or share you can say. So this is what we understand from mixed fraction. I hope now you had the clarity of mixed fraction. Equivalent fraction. Two fractions are said to be equivalent if the shares are selected from the equal unequal parts of the whole are same. An equivalent fraction can be obtained by multiplying or dividing the numerator and denominator by the same number. Here you can see that 1 by 2 is a proper fraction. It has been multiplied both numerator and denominator with the number 2, and we get 2 by 4. Then multiplied with 3, we get 6 upon 12, then 10, 60 upon 120. So here we see that all the fractions are equivalent to each other, because whenever you are going to convert them in their reduced simplest form, you are going to reduce them in simplest form, it will be 1 upon 2. So when you divide 2 upon 4 by 2, it will be 1 by 2. 6 by 12, when you divide it by 3, it will be 1 by 2. So we see that the equivalent fractions can be obtained by multiplying or by dividing but with the same number. Numerator and denominator both are multiplied with the same number. So here we have an example of 1 upon 2, 2 by 4, and then 3 upon 6 and 4 upon 8. So all these are you can say the equivalent to 1 by 2. So I hope you are clear about the equivalent fraction, and it's various example how we can give the example of equivalent and how we can find the equivalent fractions either by multiplying or dividing the numerator or denominator with the same number. Next we have to compare two fractions. So how we are going to compare two fractions? We are going to observe the numerators and the denominators of the fractions. So here we have 2 upon 6 and 2 upon 3. So when the numerators and the denominators are same or different or both are different, so there are three cases here. When the numerators are same and denominators are different, so when the numerators we have same and denominators different, so denominator with a smaller value is the larger fraction. So here 2 upon 3 will be larger as compared to 2 upon 6, and you can understand it in this way also. If 2 is to be divided, rupees 2 is to be divided among 3 people and rupees 2 is to be divided among 6 people, share of 3 people will be larger as compared to share of 6 people. So this is what we understand from here. Now next we have the example 2 upon 8 and 1 upon 4. Here we have the example of 5 upon 8 and 3 upon 8. So now when the numerators are different and the denominators are same, this is the case where we need to understand here. So 5 is the larger value as compared to 3. So 5 upon 8 will be larger than 3 upon 8. So we observe the larger numerator when the denominators are same. The fraction with larger value of the numerator will be larger fraction. So when the numerator and denominator both are different, in that case either we need to convert the given fraction into equivalent fraction by and changing the denominators and numerators, making them equal. So here you have 3 and 4. We have the LCM 12. So we can multiply 2 by 3 by 4. 2 4s are 8 and 3 4s are 12. So we will get an equivalent of this. That will be 8 upon 12. And we can multiply 3 upon 4 with 3. It will be 9 upon 12. So 8 upon 12 and 9 upon 12. Now we can compare them. So 9 upon 12 will be larger as compared to 8 upon 12. So 3 by 4 is a larger fraction as compared to 2 by 3, just by converting and finding the equivalent of these two fractions, making the denominator equal, or you can make numerator equal as well. So this is how we compare the two given fractions whenever the denominators are same, numerators are same, or both are different. Now next is addition of fractions. So here we have the concept of LCM of the denominator, and when the denominators are same, so the LCM of 5 and 5 will be same here. So we take the LCM of 5 and we write the denominator as 5 here, and we simply add the given numerator 1 and 2 will be added here. So you can see 1 upon 5 and 2 upon 5 both are to be added. So if you add them, so it will be 2 plus 1, 3 upon 5. So 3 upon 5 is the answer. So whenever the denominators are same and the numerators are different, so you are going to add simply the numerators. So 1 plus 2, 3 added, and it becomes 3 upon 5. So there are total 5 equal parts of a whole, and one part is selected, and we have the 2 parts selected from the same whole. So if we talk about from the same whole, which we have the 5 equal divisions, how many parts are selected? 1 plus 2, 3 parts are selected out of 4 equal parts of the same whole. So this is what the concept of addition we understand when the new denominators are same. When the denominators are different, we find again the equivalent fraction of the given fraction. So 1 upon 5, here 5 is a factor of 15. So we convert 5 we make it 15 by multiplying with a number, both numerator and denominator. So we find the equivalent of 1 upon 5 and we get 3 upon 15. Now denominators are same and the numerators are added, so we get 10 upon 15, and its simplest value we get by dividing it by the HCF of 10 and 15. So here 10 upon 15 we have divided it by 5 because 5 is the HCF of both. So it will be 2 upon 3, the correct answer, while we are going to add the 7 upon 15 plus 1 upon 5. So I hope the addition of fractions where we have the concept of taking LCM and finding the equivalent fractions clear to you. Now next we have the subtraction of fractions. The concept is same as we have done in previous slide, the addition concept. Denominators are same, so simply subtract the numerator. So there are total 8 division of 8 equal parts of a whole, and 5 parts are selected, and from the same 8 equal parts 2 parts are selected, and you are subtracting the selected part 5 upon 8 and minus 2 upon 8. So what you are left with is 3 upon 8. So we see that whenever the denominators are same, we simply subtract the numerator value, and this is what we understand from the subtraction of fractions. So here we have different denominators. So what we do, we make the denominators equal by finding their equivalents. So here we converted 4 into 12 by multiplying with 3, both numerator as well as denominator. So it's 9 upon 12, and here we have 4 upon 12. So now we are going to subtract 9 upon 12 and 4 upon 12. So it becomes 5 upon 12 here. So this is the correct answer, 5 upon 12, 9 minus 4, 5 upon 12. So when denominators are different, again the concept is same. You need to convert the given fraction into its equivalent form. So here we 3 upon 5 we have, we found the equivalent of 3 upon 5, that is 9 upon 15, and now the denominators are same, so simply we subtracted. So in case of both addition of fractions and subtraction of fractions, we need to apply the concept of taking LCM, finding the equivalent fractions, making the denominators equal, and then we simply add or subtract the given numerators of the fractions. Now next we have the exercise 2.1, where we have the 8 questions, and we are going to discuss each questions in detail, how to solve them and how to find their answers. So the very first question you can see here, we are going to find the addition and subtraction of fractions. So first part of the question number 1 is 2 minus 3 upon 5. So we can consider 2 as 2 upon 1 and then minus 3 upon 5. Again we take LCM of 1 and 5, and you can say you convert the given fraction to its equivalent form. So 2 upon 1, so you require this, you need to make the denominator same, so you need to make this 1 to be to 5, so you need to multiply with 5 here. So 1 5 times become 5 in denominator, and 2 5 times become 10. So 10 minus 3 upon 5, this is what you are doing by converting the denominator, making the denominator same in both the fractions. Or you can take you can also understand in another way, that is 1 and 5, their LCM is 5 here, and then you see that 1 goes 5 times, so 2 goes 5 times 10, and then minus 3. So here we have the answer 7 upon 15. Now in case of second part, again where we have the addition of two fractions, so 4 can be considered as 4 upon 1 and 7 upon 8, again converting and making the denominator same or finding the equivalent fraction. So here we have 7 upon 8, so 1 can be converted into 8 by multiplying with 8 here, and 4 8 times become 32, so 32 upon 8, 8 is the common now same denominator, and then simply numerators are added, so it becomes 39 upon 8 is the correct answer. So all the parts are done in the same way. You can see here all the parts, the in case of this part, the mixed fraction has been converted into the improper fractions, and then again their denominators, you can say taken LCM, so 3 and 2 LCM is 6, so this is to be converted into 6, and this is also to be converted into 6. 3 to be multiplied by 2, so 8 times 2 will be 16, and 2 multiplied with 3, so here we have 6, so 7 3 times 21, and we have added them. So in all the parts, the concept of taking LCM and making the denominators equal by finding their equivalents, the concept is same here. Now next question number 2, we are going to compare these three fractions, the part 1, and we are going to find the LCM of the denominators, that is 63, and we are going to convert all the denominators into 63 by multiplying with a number with both numerator and denominator. So 7 times 9 becomes 63, and 2 times 7 becomes 14. So again this 2 upon 3 21 times, it becomes 42 upon 63, and then 8 upon 21, it is 3 times 24 upon 63. Now we can easily compare when the denominators are same. So 14 upon 63, 42 upon 63, and 24 upon 63. So this is the value 42, the numerator with the largest value. So 42 upon 63 is larger than 24 upon 63, and then 14 upon 63. So now we can convert them into their reduced form and simplest form. So we now compare 42 upon 63 is 2 by 3. So 2 by 3 is the given fraction, which is the largest one, and then we have 8 upon 21, because 24 upon 63 we have 8 upon 21, and 14 upon 63 we have 2 upon 9. So this is how we compare the fractions, by converting them into by finding their equivalent fractions. So now here we have the now here we have the question number 3, and the question number 3 is saying that in a magic square, the sum of numbers in each row and each column and along the diagonals is the same. Is this a magic square or not? So along the first row, the sum of the values or fractions given here, the numbers, their sum is 15 upon 11, and we see that the sum along all the columns and along each row and diagonal, both the diagonal, we say the sum is 15 upon 11. So here we say that this is a magic square because the sum is same along each row, each column and each diagonal. So this is what you need to do in question number 3. Now next we have the question number 4, and here we are supposed to find the perimeter of a given rectangle, and where we have the length and breadth of the rectangle. So length is 12 1 by 2, which we have to convert into improper fraction. So 12 1 by 2 becomes 12 plus 1 by 2, and it becomes 25 upon 2. So 12.5 centimeter. So 25 upon 2 centimeter. 10 2 by 3 centimeter means 32 upon 3 centimeter. 10 plus 2 by 3, and then you will add them and it will become improper fraction 32 upon 3 centimeter. So the perimeter of rectangle, we know the formula here is twice length plus breadth, and we have added the both length and breadth in which are improper fractions, and we have taken the LCM of 2 and 3, that means 6. So 2 goes 3 times, so 25 will also go 3 times, and it will be 75, and 3 goes 2 times here, so 32 2 times also, it becomes 64, and we have got the 139 upon 6, and then it 2 times we have got the mixed fraction, that is 46 1 upon 3 centimeter. So the perimeter of the given rectangle where we have the length and breadth is 46 1 upon 3 centimeters. So I hope you understood and you now have the clarity of this question, how we need to solve it. Now question number 5, again we are supposed to find the perimeter of triangle ABE, where the perimeter of a triangle, we add all the sides given to us. So side lengths are given 5 by 2 centimeter, 2 3 by 4 centimeter, and 3 by 5 centimeter. So we have added all the parts, and mixed fraction got converted into improper fraction 2 plus 3 by 4. 2 3 by 4 means 2 plus 3 by 4, and when you will add 2 plus 3 by 4, it will become an improper fraction, that will be 11 by 4. And finally we got 2 4 5, the LCM is 20, so 2 goes 10 times to become 20, so 5 becomes 10 times 50, so 4 goes 5 times, so 11 5 times 55, and 5 4 times becomes here 20, then 18 4 times 72, and finally we add them and we see that 177 upon 20 centimeter, or you divide 177 by 20, you will get the quotient 8 and the remainder is 17. So here we have the 8 17 upon 20 centimeter as the answer or perimeter of triangle ABE. Now next we have the question number 5, second part, again the concept of perimeter of rectangle. So we have already discussed this in previous slide, so I hope you have the same concept, twice length plus breadth, and you have to add them and you need to find the perimeter of the rectangle. Now next we have the question number 6. Here the width of the picture is given to us and width of the frame is given to us also. So the picture is to be trimmed so that it can fit into the frame. So the size of the frame is 73 upon 10, and the size of the width of the picture is 38 upon 5 centimeters. So both the width we have here, and we see that the picture is to be fit into we have to take the picture, and this is to be trimmed so that it can fit inside the frame. So how much part of the picture is to be trimmed, we can find that by subtracting the given values. So what we are going to do here, we are going to subtract the width of the frame from the width of the picture, because width of the picture is more larger as compared to the width of the frame. So 7 3 upon 5 and 7 3 upon 10. So 7 is the same whole number in both the cases, but fraction 3 upon 5 and 3 upon 10. So 3 upon 5 is the larger value because denominator is lesser here as compared to 10. So the width of picture is more than the width of frame. So picture is to be trimmed. By subtracting both the values here, we can get the how much width or the part of the picture is to be trimmed here. So we get the difference of both the fractions. So mixed fraction got converted into improper again, 7 plus 3 upon 5 and then 38 upon 5, and again 7 3 upon 10. So you add 7 plus 3 by 10 and improper fraction becomes 73 upon 10. So finally the width that is to be trimmed is 3 upon 10 centimeter of the picture. I hope now you have the clarity of this solution. Question number 7. Question number 7 is the part of apple eaten by Ritu is 3 upon 5 and the part of the apple that is eaten by Somu is 1 minus part of the apple eaten by Ritu. So we are supposed to find here what is the part of Ritu's more than the part of Somu here, right? So you can see the whole apple is 1, so the part you need to subtract from here, that part which eaten by Ritu. So you have to subtract 1 minus 3 upon 5 and it becomes 2 upon 5. You again take denominator as 1 upon 1 and take LCM, and then you convert the you take the LCM of both the denominators. It is 5, so 1 goes 5 times, so 5 minus 3, 2 upon 5 is the part or share of apple taken by Somu. Now we have 3 upon 5 larger than 2 upon 5, so Ritu ate larger share of apple. So by how much you subtract it? So 3 upon 5 minus 2 upon 5, 1 upon 5 is the share or part, extra part taken by Ritu. So now next we have the last question number 8 here. So time taken by Michelle to color a picture, that is 7 upon 12 hour, and the time taken by Vaibhav is 3 upon 4 hour coloring the picture, right? So now we need to convert them into equivalent fractions and then we have to compare them. So here we have 3 upon 4, so it got converted into 9 upon 12 by multiplying with 3. So we can easily compare the fractions when the denominators are same. So 4 is to be multiplied with 3 and 3 is also to be multiplied with 3, so it becomes 9 upon 12. So this is what we now have the equivalent of 3 upon 4 as 9 upon 12, and we compare it. So 9 upon 12 is larger than 7 upon 12, therefore Vaibhav worked longer, and difference of both the fractions we have got 2 upon 12, that is 1 upon 6 hour. So Vaibhav took 1 upon 6 hour more than Michelle. So this is what we understand from this question number 8. Thank you. God bless you all. Please like, share and subscribe the channel for more videos. Thank you.